Hi, grade 10s. Welcome to part 2 of probability. We are going to solve the first problem here, and let's read it. It reads as follows. The events A and B are mutually exclusive such that the probability of B is 3 times the probability of A, and the probability of A or B is 0.68. We are asked to determine the probability of B. Grade 10s, it is very important that when you read a mathematics problem, try to underline the important information, especially when it comes to probability. Let's look at what is said here. They are saying the probability is mutual, the probabilities of A and B are mutually exclusive. At this point in time, you stop and try to think about what is it that you know about mutually exclusive events. Well, by mutually exclusive events, we remember the following, that the probability of A or B is given by the sum of the probabilities, the probability of A plus the probability of B. So I hope you still remember the following. So also look at the information here. They are saying the probability of B is 3 times the probability of A, which means if you wanted to replace the probability of B, you could replace it by 3 times the probability of A. Alternatively, if you wanted to rewrite this formula, you can rewrite it as follows, that the probability of A is 1/3 the probability of B if you want to replace A in this formula and write it in terms of B. So it's totally up to you. It's totally up to you really what you want to do in this case. So we are also given the probability of A or B, which makes our life very easy. So at this point in time, I think it would be wise to just copy this formula or just look it up, and in the formula book, if they do give it to you, then you just rewrite it as exactly the way it is. So the probability of A or B is equals to the probability of A plus the probability of B. Again, grade 10s, in this case, we are confronted with the decision. What do we do with these two probabilities, the probability of A and the probability of B? It's totally up to you. Again, if you want to replace the probability of B by 3 times the probability of A, and then find the probability of A and then multiply it by 3 to get the probability of B, then that is totally fine. But I think I would go with that route in this case, just for cleanliness, just for neatness. Otherwise, because I'm trying to run away from these fractions, so let's just do that. So let's substitute what we know about the probability of A or B. We are told that it is 0.68. There it is. I just substituted that. There's nothing much that I did here. The probability of A is unknown. Okay, this is a problem. Again, this is a serious problem. Not too much of a problem if you're just going to substitute the formula the way it is. So we now know the probability of A is just the probability of A, but we do know the probability of B is 3 times the probability of A, which means 0.68 is equals to 1 probability of A plus 3 probability of A, which gives us 4 probabilities of A. Then if you want the single probability of A, we will then be forced to divide both sides by 4, which we will then use our calculator to do so. Then we are just going to take 0.68 here. We'll say 0.68 divided by 4 to find the probability of B, which is 17 over 100, which is 0.17. So we just found that this is 0.17. Therefore, since we know the following, we know that the probability, since we are asked to determine the probability of B, we know that the probability of B, we are told here that it is 3 times the probability of A. That's what we are going to do. We're just going to say 3 times 0.17, and that will give us the answer which we'll press on our calculator and just say 3 times 0.17 to get the answer. We will end up with 0.51, and our final answer will be 0.51 for the probability of B. So you could have chosen to do it the other way around by just directly replacing A and writing it in terms of B, so that you won't have this extra step to do that. But I chose to do it in the simplest way possible. Now, before we run out of time, let me try to go through the second problem in this video. So we are given other two events, A and B, are mutually exclusive. Again, I did tell you that they will most likely ask you about these events in grade 10. So they are saying the two events, A and B, are mutually exclusive. But look at the way they've written this. They are saying the probability of B stripe. I hope you remember what this means. It means the probability of not B, okay, is 0.4. But if you see this, I hope you remember that means this event is mutually exclusive, but it's also complementary. So when you are given the probability of not B, we know that 1 minus the probability of B should be the formula. So you should be thinking in those terms. So they want the probability of A or B. And if you think about this, either this formula or the other probability identity formula does not have not B. So this is why you have to immediately try to change that and write using this formula so that you can figure out maybe the probability of B, which you can rewrite as well like this. The probability of B is 1 minus the probability of not B, because that is certainly what you would need in this equation. So we are asked to determine the probability of A. So for the mere fact that we are told that the two events are mutually exclusive, let's just try to write down that our formula so that we can determine or figure out what is it that we need to do. The probability of A or B is given by the probability of A plus the probability of B. Okay, so you see that they gave you the probability of not B. Then we need to determine the probability of B, because we are definitely going to need that. Otherwise, everything else is given to us. This stuff, here it is. The probability of A, that's what we're looking for, but we're not given the probability of B. We're given the probability of not A. So it is wise to do that and calculate it here. Let's calculate that immediately. The probability of B must be given by 1 minus the probability of not B, which is 1 minus 0.4, which if we press our calculator, that must be 0.6. Okay, so the probability of B is going to be given by 0.6. Then we can calculate the probability of A using that formula. So this is given to us that this is 0.7, and we're looking for the probability of A. When we now know the probability of B is 0.6, so we can simply take this one to that side. Then we are going to have the probability of A as 0.7 minus 0.6, which then gives us 0.1. So that's the answer for this part of the problem. Great chance. I am tempted to leave this problem as a challenge for you, but I know you don't have that time. Let's try to quickly do it together so that we can figure out what to do here. So you're given the probability. Let me come back to this part. Okay, let me come back and leave this as a challenge, because I see I omitted some questions here that we're supposed to ask you. But I think the first question here is that we need to calculate whether calculate the probability of A or B if the two events are mutually exclusive. That's what the question was. Okay, calculate if they are mutually exclusive. Well, let's try to do that, because we do know that the probability of A or B for mutually exclusive events must be given just by the sum of the two probabilities. So this is the easiest. It's not supposed to be a challenge at all. I do know that there's a second question here, but that's not a grade 10 question. It's a grade 11 question. So that's why I'm leaving it like that. So let's try to quickly solve this one. So that would be 0.3, because that's given to us there, plus 0.5. So if these two events are mutually exclusive, then this would be 0.8. So there it is. So I hope you understand now how to apply the formula for mutually exclusive event, and most importantly, the formula for complementary events. So in many cases, if they really want to make the exam difficult, they might give you a situation like this, where they gave you the probability of not B and then ask you to calculate something that is totally unrelated. If you don't see that it is related by means of this formula, then you would mess up in this problem and think that they gave you the probability of B, whereas they did not give you that. So just be careful here. So I hope you enjoyed this problem. Please do come back for part 3.